system. So if you know about the solar system, so in origin and process of formation of solar system, so you should learn about the origin of the earth. So in general, there are several theories which are going to be origin of the solar system, can be divided into broadly two groups. So they are evolutionary theory and catastrophic theory. So there are two theories which are going to be explained about the solar system. So these two theories are, one is evolutionary theory and another one is catastrophic theory. The first one, let us say about the evolutionary theory. So the evolutionary theory, so theories which suggest that a planets are formed during the evolution of the sun are called evolutionary theory. So it is, the evolutionary theory suggested that the planets are formed during the evolution of the sun are called evolutionary theory. So for example, nebular hypothesis is an example of this theories. So here, generally, and catastrophic theories are those which imagine that planets are formed by some special accident or catastrophes, such as the close approach of two stars or by collision of two stars. However, as the stars are so far apart in the galaxy, so here the evolutionary theory which is evolved from the, or the evolution of the sun during the which has been, the planets are formed during the evolution of the sun. The other planets are also formed, which is suggested by the a concept of evolutionary theory. But whereas the catastrophic theory, so it is going to suggest that those which imagine that planets are formed by some special accident or catastrophism or collision. So such as the close approach of two stars. So when the two stars are approached to one another or closing, they are closely approached to one another, or collision of these two stars. However, the stars are so far apart in the galaxy. So here the possibility of the such as catastrophic extremely rare. So the example of catastrophic theories are blessed, which is going to be planetesimal theory and the gaseous theory and tidal hypothesis theories, which are going to explain about the catastrophic phenomena. So here, the best known hypothesis for the origin of the Earth or solar system or other planets. So there are five theories which are going to be explained. The origin of the solar system or formation of the solar system. They are number one, nebular hypothesis. Number two, planetesimal hypothesis. Number three, gaseous tidal hypothesis. Number four, binary star hypothesis. Number five, gas dust cloud hypothesis. So these five theories which are going to explain about the process of formation or origin of the solar system or Earth. So first let us describe about the first one, nebular hypothesis. Nebular hypothesis. So here the nebular hypothesis was put forward by Kant and Laplace. The nebular hypothesis was proposed by Kant and Laplace. So in the year 1755, Kant and Laplace was proposed the nebular hypothesis. So Kant belongs to German philosopher, whereas the Laplace is a French mathematician. Kant is a German philosopher and Laplace is the French mathematician. So both scientists, Kant and Laplace, together they have proposed the nebular hypothesis. Nebular hypothesis. So this hypothesis suggests that the sun and planets, including the Earth, have formed from disc-shaped rotating nebula. According to this theory. This theory suggests that sun and planets, including the Earth, have formed from a disc-shaped rotating nebula. So these planets are suns which are formed from a disc-shaped rotating nebula. One is a rotating nebula, a very rapid speed of rotating nebula. From this disc-shaped rotating nebula, all these planets are formed. So according to this theory of nebular hypothesis. So a vast cloud of hot gas. What is nebula? A nebula is a vast cloud of hot gas is called nebula. A vast cloud of hot gas. So this nebula is a very hot material. It is a hot gassy material. So the nebular hypothesis may be summarized some of the following things. So one is originally there was a large hot gaseous nebula which rotated along its axis. Along its axis. So these axes which are going to be along its a certain axis, there is a hot and gaseous nebula which has rotated as the gas lost its energy by radiation. Nebula is a hot gaseous material, hot gaseous body of a rapid rotating mass of gas. So, as the gas lost its energy by radiation, it became cooler. So, as a result, the nebula contracted inward and its speed of rotation about its axis increased to conserve the angular momentum. So due to this, the centrifugal force in the equatorial zones also increased, thereby causing the nebula to bulge out into the equatorial zone. So this gaseous cloudy material, when it's rotating, when it's rotating disc shaped, so when it has been cooler, when it's conserved as angular momentum, it has been these particles are going to be cooler. All these particles they are going to form as a planets. So these cooling and contraction of the nebula, this cooling and contraction of the nebula continued and ultimately a stage where it has been seen very clearly the centrifugal force became a greater than the where the conditional or where it has been seen the clear where it has been seen the disk shaped rotator or disk shaped routine of rotate of these gases of nebula, which are going to be formed or whatever when it's going to be conserved the particles, which has been spread towards the disk shaped rotator. All these disk shaped particles are going to be condensed, means they become a cooler condition. When they are cooler, all the particles they are going to form an individual mass. So these individual mass or these individual particles, they are become as a individual planets. So like that, the planetary system has evolved as per the nebular hypothesis. So nebular hypothesis is proposed by Kant and Laplace. So these two scientists are proposed nebular concept. Now I'm going to show you the pictures of how the nebular it is going to be seen in various aspects also. So just in okay. Now you can see the illustration diagram of the how the planets are formed. Yeah, here Yeah, you can see this. This is how it is going to be shown. Yeah, this is, you can see. Are you able to see this picture?
Sir, page number
Yeah, page number is 6. Okay, this is the figure 1.1 is showing the nebular hypothesis, how it is nebula in a gaseous ring with nebula and all the formations, sealed rings, the ring condensed into planets. So, which has been very clearly shows that the different distinguished materials which are going to be seen, where it has what you can call it as the things which are going to be seen, the various aspect of the figure. So all which has quietly resembled. I will say this. This is a cloudy disc-shaped material. I will say this is the first one where I focusing this. Yeah, this is nebula. I will say this. So in this nebula, so whatever the a gaseous cloudy material, the gases a cloudy material which is going to be formed. This is nebula. Yes, the arrow mark is indicating a nebula, just a round mass. So this is a gaseous, hot gases or cloudy mass material and a disc-shaped rotating body. So from this, when it has been the particles conserved, it's going to be cooler, and all the particles. Just see the diagram C, right side. Along the axis, the particles are going to become as an individual mass. So these individual mass became as a individual planets.
Excuse me, sir. Sir, my books
Yes.
no diagrams level, sir.
You don't have book?
I have a book.
Yes. In your book, these books, these diagrams are not there?
Yes, sir, not there, sir.
Okay, no problem. I will post in your group also. You can take. For understanding, I will refer the other books. I am going to explain by dramatic way.
Okay, sir. Thank you, sir.
Okay, I will post this material also. You can read this one. You can use it to understand. Okay. I will post in the group also. After completion of class, I will post in the group. You can see it.
Okay.
Right? Yeah, this is in figure C. It has been seen. So from the nebula, a small individual parts they are going to be conserved and cooler, and they became as a planets. So in solar system, what is solar system? All the planets and meteoroids in a galaxy, including sun, all this comes under, we can call it as solar system. So in the solar system, so whatever the planets which are formed from the a hot nebula, so this is a evolutionary theory, comes under evolutionary. They are evolved from the during formation of the sun. How? By the process of a nebula. A nebula is a hot gaseous material which is while it is rotating in disk shape, the particles are going to be conserved and cooler. These particles they are became as a planets. So this is very clearly showing in center diagram. This is a ring shape. Diagram B, it has showing a ring shape or disc shape. Coming to diagram D, I will see this in center particle it became as sun, and around the other particles around the center particle they are become as individual planets like Earth, Mars, Jupiter, Saturn, Uranus, Neptune, like that. Yes. So these are the individual planets. So this is very clearly shows that how the formation of solar system. Okay, which is very clearly shows that in a solar system based on the nebular hypothesis. So and also coming to planetesimal hypothesis. So the planetesimal hypothesis, which are mostly very clearly shows that how the planetesimal hypothesis was proposed by a Chamberlain and Moulton. Chamberlain and Moulton in the year 1904. The main points of this hypothesis are majorly the sun. The sun existed before the formation of planets. According to this theory, the sun existed before the formation of planets. A large passing of such as only the thing which is going to be seen very clearly, a large passing star approached very close to the sun. So it means, according to this phenomena or according to this concept, mostly the planets after the formation of the sun, a large passing star approached very close to the sun. So a large passing star is going to approach towards to close to the sun. Why? Because sun is already formed according to this theory or planetesimal theory, which is proposed by Chamberlain and Moulton. Okay, so as a theory, due to the destructive forces of the sun and the strong gravitational pull of the passing star, a giant masses of gas were torn from the surface of the pre-existing suns. So as we see, the different material which is going to be collision towards to the sun, so ultimately these are going to become as a collision, so that the other planets which are going to form. See, this is very clearly showing how this is a planetesimal theory. So the planetesimal theory is very clearly showing. See, this is figure 1.2, planetesimal hypothesis is showing very clearly. So when a large passing star is going to approach to very close to the sun, so due to the destructive forces of the sun and the strong gravitational pull of the passing star, a giant masses of gas were torn from the surface of the pre-existing sun. So due to the approachment or gravitational forces, I will say this, from the sun, some of the material is going to be split out from the sun, and these material again they are going to form as a star. It means they are going to form as a individual planets. So the giant means large size. Giant means large size. So the giant mass of gas broke into a large number of small chunks, which on cooling gave rise to solid particles called planetesimals. Planetesimals, nothing but planets. After the planetesimal, they are evolved as planets. So the thing is, you need to understand that you have to understand that. So according to this theory, there is a large star material. One of the large star is going to passing near the sun. Due to the gravitational forces, some of the material of the sun is going to pushed away. So these particles became as planetesimals, nothing but planets. These solid particles, they are become as a planetesimals. So the planetesimal started flying as cold bodies into orbits around the sun in the plane of the passing star. So by collision and gravitational attraction, we can able to understand where it is going to be seen very clearly. The thing is, so we need to understand whatever the materials which was very past to the very closer to the sun, then there is, due to the gravitational forces, some of the material from the sun it has pulled away, so that they are going to become as a individual masses such as a small planetesimals. So they are become as a planets. So from this theory, we can able to learn there is a collision between the huge star passing material coming from the approaching to the towards sun, so that it has been resulted. Then another theory, which is a gaseous tidal hypothesis. This is a third theory, gaseous tidal hypothesis. So this hypothesis was proposed by Jeans and Jeffries. Gaseous tidal hypothesis is proposed by Jeans and Jeffries in the year 1925. In the year 1925. So the gaseous tidal hypothesis may be summarized. It has been very clearly shows that a very large star progressively approached close to the sun. It means planetesimal theory and whatever the previous theory, planetesimal theory and gaseous tidal hypothesis, both are almost similar phenomena. Okay, similar principle. So even planetesimal theory, the large star material which is going to be approached to the sun, then it has been some of the particles are evolved and these particles are became as a individual planets. Like in the gaseous tidal hypothesis also, even the gaseous tidal hypothesis also, a very large star progressively approached close to the sun due to the gravitational pull of the star. A gaseous tide was raised on the surface of the sun. So as the star came nearer, as the star came nearer to the sun, so the tide increased in the size. So when the star began to move away, the star is began to move away, or it's going to be splitting some of the small particles, so that the gaseous tide was detached from the main sun or sun particle. So its shape was like a spindle being a thickest in the middle, so that here some small difference we could have to we could have to identify the difference between the planetesimal theory and the gaseous tidal hypothesis. Gaseous planetesimal theories already sun is existed. After some of the star material is going to approach to the nearer to the sun, then other planets will be formed. But here the gases, according to the gaseous tidal hypothesis, so here due to the collision of the star material, star to the approach to the sun material which has been spread out in various particles. So whatever the center, which means whatever the remaining in center, it became as a sun, and rest of the other particles are there became as a planets. Yes. So here this is a way of how the solar system has formed. Then in these are the evolutionary theories. Some are catastrophic theories. Evolutionary theory means they are going to examine and estimation how the solar system has going to be taken place to formation. And these two, the concept is two concepts. One is evolutionary concept, another one is catastrophism. Catastrophism means to collision. ఒకదానికోటి గుద్దుకోవడం వల్ల అంటే has been accident between the two planetary material or two star materials, so that the individual other planets are full-fledged planets are formed, or whatever the solar system planets do we have right now, all these planets are formed. So this is about the how solar system has formed. Then coming to the age of the earth. Age of the earth. So here generally the age of the earth as determined by the current methods present nowadays. Okay, so current methods of radiometric dating. So radiometric dating is almost accurate determination of the age. So based on the current radiometric dating method, means what does it mean by radiometric dating methods? So whatever the radioactive elements are present in the rocks, yes, like uranium, thorium, rubidium, strontium, like that. So whatever the radioactive elements are present, if any radioactive elements are present in a rock, then we can determine their age by dating of such a type of rocks. Mostly, these are called we can their half-life periods, the isotopes. Yes. So the age of the Earth is based on the current methods. The radioactive based on the radioactive methods, the age of the Earth is determined as 4,600 million years. Okay, 4,600 million years. So before the discovery of radiometric dating, several attempts were made to determine the age of the Earth. So means before determining or before the discovery of radioactive methods. So radioactive is very recent. It is very, very recent method. But before the discovery of radiometric dating, several attempts are made by the various scientists. So based on the from history of organic evolution, history of organic evolution. Organic means life. Yes, organisms. So based on the history of organic evolution, from the rate of sedimentation, from salinity of seawater, from rate of cooling. So these four methods before the discovery of radiometric dating, there are several attempts are also made before this. From history of organic evolution, organic evolution means organic life. How the as we know, if you are biology BJG student, means botany zoology students, you can able to understand how the plants are evolved from the simple plants to become simple plants to highly evolved or highly developed plants like trees. Yes, from monocots to dicots, or from Bryophyta to Pteridophyta, then after gymnosperms, like that. So the simplest plants are evolved today, the huge developed or big trees, how it has evolution. Then coming to animals, beginning from we have the single cellular organisms. Yes, single cellular means ekakana జీవులు అంటాం కదా, like protozoans, bacteria, virus. Yes, these are the single cellular organisms, ekakana జీవులు. So they are made up of only one cell, and also they are very simple. They are very simple. Why? Because being a single cell, there is no all the distinguished systems are not developed. If you find out, if you take the bacteria, there is no respiratory system, there is no circulatory system, there is no digestive system. Yes, but we have all these systems and well developed systems. The human being is a highly lost evolved. Yes, the lost evolutionary body, the human beings means we are having all full-fledged systems. Specific organs are there to perform specific functions in our body. Each and every lung system is there to respiratory system, heart system is there to circulatory system, digestive system there to digest the material. Like each and every what you can call it as the different or individual organs are there to perform different functions. Yes, in our body. So this is evolution. So evolution, it is not in a single line, or it is not in a simple way. Evolution is a very complex process, and it's a continuous process also. Yes. So like that, during the organic evolution, the age of the earth means from when the ancient life was started, bacteria, single cellular organisms, when these unicellular organisms, based on this evolution of life, they are identified as the age of the earth is 1,000 million years, just 1,000 million years. That is one attempt regarding to the age of the earth, based on the history of organic evolution. Then coming to the from rate of sedimentation. rate of sedimentation. What does it mean by sedimentation? As we know, the sedimentation process, mostly we can see the sedimentation in the low-lying areas. Yes, low-lying areas. Low-lying areas అంటే ఏంటి? Maybe lakes, maybe ponds, maybe rivers, maybe oceans, maybe seas. Yes, these are the low-lying areas. అంటే like లోతట్టు ప్రాంతాలు అంటాం కదా మనం, చెరువులు, కుంటలు, సముద్రాలు, మహాసముద్రాలు. సో దీస్ ఆల్ కమ్స్ అండర్ ఏ low-lying areas. సో ఇక్కడ ఏం జరుగుతుంది మనకు? నిత్యం ఎవ్రీడే ద కంటిన్యూస్లీ sedimentation process taking place. Sedimentation means some of the particles will all continuously carried from the various places and deposited in the lakes, ponds, oceans and seas. Yes, why? Because when it's raining, for example, when it's raining, the rainwater, the simple, the what you can call it as in general, the small streams, చిన్న చిన్న కాలువలు ఏం చేస్తాయి? పెద్ద కాలువతో కలుస్తాయి. పెద్ద కాలువలు ఎక్కడ పడుస్తాయి? చెరువులు. చెరువులు ఎక్కడ? లేక్స్. లేక్స్ మళ్ళీ రివర్స్తో. రివర్స్లోనే ఎక్కడ కలుస్తాయి? చివరికి అల్టిమేట్గా ఓషన్లో కలుస్తాయి. అవునా? సో దిస్ ఈజ్ వే, ఇన్ దిస్ వే వెన్ ఇట్స్ రైనింగ్, ది రెయిన్ వాటర్ విల్ క్యారీ ద ఫైన్ పార్టికల్ విచ్ ఇస్ ఆన్ ది సర్ఫేస్ ఆఫ్ ది అర్త్. ఎస్, భూమి పైన ఉన్నటువంటి ఫైన్ పార్టికల్స్, లూజ్గా ఉన్నటువంటి సెడిమెంట్స్ అయితే ఉంటాయో, పార్టికల్స్ అయితే ఉంటాయో, ఈవెన్ ఇంక్లూడింగ్ డస్ట్, సాయిల్, లూజ్ సాయిల్ ఐ మీన్. సో ఇదంతా ఏమైతే వర్షం నీటితో ఏమైతుంది? కొట్టుకపోదు. ఇట్ ఈస్ ట్రాన్స్పోర్టెడ్. దట్ మెటీరియల్ ఈస్ గోయింగ్ టు ట్రాన్స్పోర్ట్ బై ది రెయిన్ వాటర్. ఎక్కడ చేరుతుంది కొట్టుకుపోయిన మట్టి? చెరువులో కావచ్చు, కుంటల్లో కావచ్చు, లేక్స్లో కావచ్చు, ఫైనల్లీ ఓషన్స్లోకి వెళ్తుంది. అంటే స్ట్రీమ్స్. చెరువు ఉంది అనుకోండి, చెరువు చుట్టూ ఏముంటాయి? చుట్టుపక్కల ఉన్నటువంటి ఏరియాస్ నుంచి ఒక 1 కిలోమీటర్ 2 కిలోమీటర్స్ ఏరియాస్ నుంచి ఉన్నటువంటి స్ట్రీమ్స్ అన్ని కూడా వచ్చి ఆ చెరువులో జాయిన్ అవుతాయి. అవునా? అంటే చుట్టుపక్కల ఉన్నటువంటి సాయిల్ అంతా వచ్చి చెరువులో జాయిన్ అవుతుంది. అంటే దీనివల్ల ఏమవుతుంది? సెడిమెంట్స్ అంటే పార్టికల్స్ ఏవైతున్నాయో, ఫైన్ మెటీరియల్ ఏదైతే ఉందో, ఫైన్ సాయిల్ ఏదైతే ఉందో, ఆటోమేటిక్గా ఏమవుతుంది? వచ్చి ఆ లేక్లో డిపాజిట్ కావడం కానీ, ఐ మీన్ పాండ్లో డిపాజిట్ కావడం కానీ, మేబీ ఓషన్లో, సీలో కానీ, లైక్ దిస్ ఎవ్రీ ఇయర్ డ్యూ టు ది రెయిన్స్ దిస్ ప్రాసెస్ ఈస్ గోయింగ్ ఆన్. అవునా కదా? ఈవెన్ యూ మైట్ హావ్ అబ్జర్వ్డ్ ఇన్ యువర్ సరౌండింగ్స్. మీరు కూడా మీ చుట్టూ ఉన్నటువంటి హౌస్ హోల్డ్ పరిసర ప్రాంతాల్లో చూడవచ్చు. మీరు ఎప్పుడైనా వర్షం పడ్డప్పుడు దూర ప్రాంతాల నుంచి మనకు ఫైన్ మెటీరియల్ వచ్చి ఎక్కడైతే కరువుగా ఉన్నటువంటి ఏరియాలో, మూలలు వంకలు ఉన్నటువంటి ప్రాంతాల్లో వచ్చి చేరుతూ ఉంటుంది. అవునా కదా? సో దిస్ ఈస్, ఇట్ హాస్ క్యారీడ్ దట్ మెటీరియల్ ఆర్ ఫైన్ సెడిమెంట్స్ ఆర్ క్యారీడ్ ఫ్రమ్ ది వేరియస్ ప్లేసెస్. ఎక్కడో సుదూర ప్రాంతాల నుంచి వచ్చి చేరుతుంటుంది. సో లైక్ దట్ ద బేస్డ్ ఆన్ ది రేట్ ఆఫ్ సెడిమెంటేషన్. అంటే ఈ రకంగా ఏంది? ప్రతి సంవత్సరం కూడా సముద్రంలో కానీ, మహాసముద్రంలో కానీ కొంత అమౌంట్ ఆఫ్ సాయిల్ ఆర్ పార్టికల్స్ ఆర్ మెటీరియల్ అనేది ఏమవుతుంది? డిపాజిట్ అంటే వచ్చి చేరుతుంది, డిపాజిట్ అవుతుంది. అవునా కదా? అంటే ప్రతిరోజు మనం నెలకు మనకు మన శాలరీ నుంచి ఒక 5,000 మన అకౌంట్లో వేసుకుంటే ఏమవుతుంటుంది? సంవత్సరానికి కొంత అమౌంట్ ఆఫ్ డిపాజిట్ అవుతుందా కదా? అట్లనే ఎవ్రీ ఇయర్ సమ్ అమౌంట్ ఆఫ్ మెటీరియల్ ఆర్ సాయిల్ పార్టికల్స్ which are going to be deposited in the low-lying areas such as lakes or ponds or rivers or maybe oceans and seas. సో ఈ రకంగా ఎవ్రీ ఇయర్ కొంత మెటీరియల్ చేరడం వల్ల ఏమవుతుంది? ఆటోమేటిక్గా ఓషానిక్ లెవెల్ అంటే ఓషానిక్ థిక్నెస్ అనేది తగ్గుతుంది. అవునా కదా? ఓషానిక్ డెప్త్ తగ్గదు. ఎందుకు? అందులో క్రమక్రమంగా సాయిల్ చేరుతుండడం ఏమైంది? దాని యొక్క థిక్నెస్ మనకు ఒక 20 years బ్యాక్ ఒక 100 meters థిక్నెస్ ఉందనుకోండి, ఒక 10 years బ్యాక్ 100 meters థిక్నెస్ ఉందనుకోండి, ఇప్పుడు కూడా అంతే థిక్నెస్ ఉంటుందా? అంతే డెప్త్ ఉంటుందా? ఉండదు. ఎందుకు? క్రమంగా ఎవ్రీ ఇయర్ డ్యూ టు ది రెయిన్స్ వల్ల ఏమవుతుంది? సాయిల్ పార్టికల్స్ అన్ని వచ్చి అందులో చేరడం వల్ల ఏమవుతుంది? దాని యొక్క లెవెల్ అనేది అంటే డెప్త్ ఆఫ్ ది ఓషన్ అనేది ఆటోమేటిక్గా డిక్రీజ్ అవుతూ ఉంటుంది. డెప్త్ తగ్గుతుంది కదా? డెప్త్ అనేది క్రమంగా తగ్గుతుంది. అంటే ఏంది? డెప్త్ తగ్గుతుంది, దాంట్లో ఉన్నటువంటి సెడిమెంట్స్ యొక్క మందం అనేది పెరుగుతూ ఉంటుంది. అవునా కదా? థిక్నెస్, పార్టికల్స్ యొక్క sedimentation of particles or deposition thickness is increasing from year to year, but the depth of the oceanic level ఏమైతే ఆటోమేటిక్గా తగ్గుతూ ఉంటుంది. అవునా కదా? జనరల్గా మనకు యాజ్ వి నో ద ఓల్డ్ స్టోరీ, సో జనరల్ ద క్రోస్ ఆర్ బ్రింగ్స్ ద స్టోన్స్ when the crow is in hungry in condition. అవునా కదా? కాకి బాగా ఆకలిగా ఉన్నప్పుడు ఏం చేస్తుంది? ఇక్కడ ఎత్తుకుంటే సమ్వేర్ ఇన్ ఏ పాట్ ఇట్ హ్యాస్ వెరీ లెస్ వాటర్. చాలా తక్కువ నీరు, unable to drink, then that is it is used to put the stones in the pot so that the water level will comes to the top so that it can be drink. అవునా కదా? అంటే దాంట్లో సెడిమెంట్స్ వేయడం వల్ల ఏమైంది, అందులో స్టోన్స్ వేయడం వల్ల ఏమైంది, ఆటోమేటిక్గా వాటర్ పైకి వచ్చేసి అంటే దాని యొక్క థిక్నెస్ తగ్గిస్తున్నాం మనం. దాని యొక్క సెడిమెంట్స్ వేయడం వల్ల ఏమవుతుంది, అదంతా కూడా సెడిమెంట్స్ క్రమక్రమంగా వేసుకుంటూ వల్ల స్లోగా నీరంతా పైకి వచ్చేస్తుంది. అంటే దాని యొక్క పార్ట్ యొక్క డెప్త్ తగ్గలేదా? స్టోన్స్ వేసుకుని పోవడం వల్ల ఏమైంది, ఆటోమేటిక్గా డెప్త్ అనేది తగ్గుతున్నది. డెప్త్ తగ్గడం వల్ల సీ లెవెల్ తగ్గుతుంది అన్నట్టు. అంటే థిక్నెస్ ఆఫ్ ది సెడిమెంట్స్ ఈజ్ ఇంక్రీజింగ్. సో అంటే ఫర్ ఎగ్జాంపుల్ పర్ ఇయర్ ఆర్ ఒక 10 years కానీ 15 years కానీ how much thickness of sediment has taken place. Now what is the total thickness of the ocean? Now what is the total sediments in a ocean? చూస్తే మనకు బేస్డ్ ఆన్ దట్, ఫర్ ఎగ్జాంపుల్ ఒక సెంటీమీటర్ మందం ఒక 1 year లో అయింది అనుకోండి, 1 centimeter థిక్నెస్ వచ్చింది ఒక 1 year లో. ఇప్పుడు మొత్తం టోటల్ థిక్నెస్ ఒక 10 centimeter ఉంటే దాని ఏజ్ ఎంత అని చెప్తాం మనం? 10 years అని చెప్తాం. 1 year లో 1 centimeter థిక్నెస్ వచ్చినప్పుడు 10 centimeter థిక్నెస్ ఉంది అనుకోండి, వాట్ ఈస్ ద ఏజ్ ఆఫ్ ది ఓషన్ అంటే 10 years అని చెప్తాం. ఎస్, లైక్ దట్ బేస్డ్ ఆన్ ది రేట్ ఆఫ్ థిక్నెస్ అంటే యావరేజ్ నా ఎన్ని ఇయర్స్ కి ఎంత సెడిమెంట్స్ డిపాజిట్ అవుతున్నాయి, బేస్డ్ ఆన్ దట్ ఎస్టిమేషన్ అండ్ క్యాలిక్యులేషన్ ద ఏజ్ ఆఫ్ ద ఎర్త్ ఈజ్ ఐడెంటిఫైడ్ యాజ్ 500 million years. 500 million years. So history of organic evolution based on that 1000 million years, rate of sedimentation based on that 500 million years. Okay, now from salinity of sea water based on the sea water. So based on the sea water, as we know everyone, sea water or oceanic water has salinity condition. అవునా? సాలినిటీ ఎక్కువగా ఉండదు. సాలినిటీ అంటే ఉప్పు శాతం. సాల్ట్ వాటర్ ఎక్కువగా ఉండదు, saline కండిషన్ ఎక్కువగా ఉంటుంది. ఓషానిక్ వాటర్, సముద్రం నీరు ఉప్పుగా ఉంటుంది కదా, సాలినిటీ ఇట్ గివ్స్ saline taste. ఓషానిక్ వాటర్ గివ్స్ saline taste. అవునా కదా? సో దట్ based on the salinity, it means every year to year. Why? Because the oceanic water gives saline condition, because the oceanic water comes from the thousands of kilometers from the far places. The water has run and come and join into the oceanic area. సముద్రంకి వచ్చే నీరంతా ఎక్కడి నుంచి వస్తుంది? కొన్ని వేల కిలోమీటర్ల నుంచి ట్రావెల్ చేసి వస్తుంది. అవునా కదా? అంటే సముద్రంలోకి వచ్చే నీరంతా కూడా కొన్ని వేల కిలోమీటర్ల నుంచి ఉన్నటువంటి రివర్స్, త్రూ ద రివర్స్, that much of far distance of water, it has been highly contact or chemically react with the soil and stones and minerals. So whatever they meanwhile their journey. For example, as we know very well, Bay of Bengal, Bangalakhatam తెలుసు మనం, Bay of Bengal. So east coast of almost ఆంధ్రప్రదేశ్ స్టేట్. అవునా? సో ఈ బే ఆఫ్ బెంగాల్ చూస్తే మనకు ఉప్పు నీరు, చాలా ఉప్పు నీరు. సో బే ఆఫ్ బెంగాల్లోకి ఏంది, మన గోదావరి రివర్ ఉంది. గోదావరి ఎక్కడ స్టార్ట్ అవుతుంది? ఇట్ హాస్ స్టార్టెడ్ ఇన్ మహారాష్ట్ర. గోదావరి రివర్ మహారాష్ట్రలో స్టార్ట్ అయ్యి తెలంగాణ అండ్ ఏపీ క్రాస్ అయ్యి ఇట్ హాస్ బీన్ మెర్జ్ ఇన్ ది బే ఆఫ్ బెంగాల్. ఇట్ హాస్ బీన్ ఎంటర్ ఇన్ టు ది బే ఆఫ్ బెంగాల్. అంటే మహారాష్ట్రలో పుట్టి తెలంగాణను మొత్తం ప్రవహించి, తెలంగాణ నుంచి ఆంధ్రప్రదేశ్, ఏపీలో ప్రవహించి అండ్ బే ఆఫ్ బెంగాల్ చేరడం వల్ల అది గోదావరి రివర్ యొక్క డిస్టెన్స్ కొన్ని థౌజండ్స్ ఆఫ్ కిలోమీటర్స్. అన్నా కదా? అంటే అంత ఫార్ డిస్టెన్స్ నుంచి ట్రావెల్ చేయడం వల్ల ఇట్ హాస్ బీన్ ట్రావెల్డ్ ఫ్రమ్ సో ఫార్ డిస్టెన్సెస్, సో దట్ the water, it has been highly chemically reacted with the meanwhile in their course of journey. So it has going to be highly contaminated with the various stones. It has been reacted with the other chemical constituents which are present in the course of journey, the soil. Like that, it is highly dissolved in condition. That water is highly dissolved in condition, so that it gives a saline condition. Salt chemical constituents is high and high, so that the oceanic water gives saline in condition. So if it is an initial ocean, it has low salinity. If it is a somewhat or 10 years, 15 years old ocean, it gives somewhat salinity. If it is a 100 years history of ocean, it has high salinity, isn't it? Why? Because క్రమక్రమం అంటే ఈ రోజు ఉన్నటువంటి సాలినిటీ ఆఫ్టర్ 10 years తర్వాత ఏమైతే సాలినిటీ ఇంకా ఇంక్రీజ్ అవుతుంది. అంటే ఎవ్రీ ఇయర్ ఏమవుతుంది, ద కన్స్టెంట్స్ ఎలిమెంట్స్ ఆర్ యాడెడ్ ఇన్ టు ది ఓషన్. ఓషానిక్ వాటర్లో నిరంతరం ఏమవుతుంది, ఓషానిక్ వాటర్ యాడ్ అవుతుంది. యాడ్ అవుతున్నప్పుడు ఏమైంది, ఆటోమేటిక్గా సోడియం పార్టికల్స్ కానీ అదర్ కాన్స్టెంట్స్ కానీ ఇఫ్ దే ఆర్ యాడెడ్ టు ది ఓషానిక్ వాటర్, definitely the saline condition is gradually increase. So based on that simple example, a glass of water lo half spoon salt వేసినాం, it has some salinity, కొంచెం ఉప్పుగా ఉంటుంది. 2 spoon వేసినాం, salinity ఏమవుతుంది, ఇంక్రీజ్ అవుతుంది. 3 spoon వేసినాం, 4 spoon వేసినాం, 5 spoon వేసినాం. So the amount of salt is going to be added every year, so that the oceanic water condition of saline condition is automatically increase అవుతా ఉంటుంది. So that based on the salinity condition, the age of the earth is determined as 120 million years. 120 million years based on the salinity of a sea water. From the salinity of sea water, the age of the earth is determined as 120 million years. Then last one, from rate of cooling. From rate of cooling. So here the rate of cooling, how it has been, the rate of cooling. So for example, it has been calculated the age of the earth from the temperature, the rate of the cool in the year 1897. The British physicist Lord Kelvin, the British physicist Lord Kelvin calculated the age of the earth from the temperature differences between the initial molten planet, from difference between the initial molten planet and its present state. So initial molten planet, so means while formation of the planets until today. So what is the temperature differences? So based on that, he is going to calculate the rate based on rate of from the rate of cooling and it is present state. He assumed that Lord Kelvin assumed that the rate of heat loss was constant throughout. This method gave an age to the earth is 20 to 40 million years. From this rate of cooling, the age of the earth is 20 to 40 million years, which was more than 100 times lower than the current estimates. అంటే ఇప్పుడు 20 to 40 years అనేది based on the current estimation method, current dating of method or current radiometric dating of method కి ఎంత రేటు తక్కువ ఉన్నది, 100 times తక్కువ లేదు. సో కరెంట్ రేడియోమెట్రిక్ ఆధారంగా ఎంత చేసినాం మనం, 4600 million years గా డిటర్మైన్ చేసినాం. So current radiometric dating, the age of the earth is 4600 million years. Yes, current method means present method of radiometric dating, the age of the earth is determined as 4600 million years. Kani if you compare to all these previous attempts before the discovery of radiometric method, so these attempts from the organic evolution, from solid from the rate of sedimentation, from the salinity of seawater, and from rate of cooling, all these very lower ages, which is not very lower ages from the date of radiometric method. But these are the previous attempts. These are ancient and previous attempts. But what we are followed, the age of the earth is 4600 million years. This is the accuracy method, accuracy and exact method of dating of by using the radiometric phenomena. Okay, so now the age of the earth is 4600 million years. Okay, 4600 600 million years. Yeah, so this is how we are going to be use and how we are going to be estimation the age of the earth and various aspects. We came to know that by the several attempts. Finally, the age of the earth is determined by the radiometric methods from potassium to argon method, and rubidium to strontium method, and uranium to lead method. So it means when potassium is turns to argon, or when rubidium turns to strontium method, or when uranium is turns to lead. So it has gives accurate age. So if these constraints are present in stones, we can easily to determine the age of the rock. So that age of the rock, the oldest rock, where is the oldest rock? Based on that, we can able to estimate and determine the age of the earth exactly. So in this way, we can able to identify or estimate or determine the age of the earth. So we have completed first block, first unit means the first unit it has general geology, the scope and the branches of geology, and the solar system, and as well as age of the earth or earth. Okay, so this is first unit, three topics: scope, geology, definition of geology, scope of geology, and solar system and earth. Okay.
సార్ ప్లీజ్ సార్ మీరు అంటే కొత్త బుక్ తీసుకోండి సార్. మీరు పాత బుక్ అనుకుంటా, ఐ థింక్ అది నాకు అర్థం అవ్వట్లేదు సార్. ఇయర్ వేరేగుంది బుక్, మీరు చూపెట్టేది వేరేగుంది సార్.
Okay. What are the basic principles is same, but okay, I will take the new edition also.
ఓకే సార్. టుమారో క్లాస్ కు మీరు కొత్త బుక్స్ తెచ్చుకోండి సార్.
Okay, sure.
ఓకే సార్, థ్యాంక్ యూ సార్.
Right. Thank you, Anna.